All right. Theorems about zeros of polynomials. Because this chapter here is now we're going to solve for equations that are nth degree. Up until now, we've had linear equations for chapter 1 and chapter 2, quadratic equations. We looked at cubic equations, but now we're looking at the degree could be anything. When we talk about zero, we're talking about the x-intercept. Or the solution. Or the factor. Or the root of the polynomial. We can solve any form of polynomial. It could be a rational polynomial. It could be well, I'll show you the types it could be. And the types of polynomials depend on their coefficient. So our coefficient, we can have in our polynomial, we can have a complex polynomial, a coefficient, which is of the form a plus bi, which means we have imaginary terms. We can have radicals, or yeah, I'm sorry, I should put it over here. Our coefficients can be real. By real, I mean it could be a fraction, it could be a complex, it could be a constant, an irrational constant, like pi. It can have a rational coefficient. So our polynomials could look at any one of these, and we will be able to solve them. Which brings us to the fundamental theorem of algebra. This is what we're looking for. It says every polynomial function p of x of degree n, with n being greater than or equal to 1, has at least one zero in the set of complex numbers. So what does that mean? Every polynomial P of X of degree n, with n being it's a positive integer greater than or equal to 1, has at least one zero in the set of complex numbers. Why complex numbers? How do you mean? What is a complex number? And when we take notes, and especially in college, learn how to abbreviate lots of things, so you don't have to write everything out by longhand. What is a complex number? What does a complex number look like? A plus bi. So a complex number could be 3. It could be -3. It could be -2i. It could be 2i. It could be 3 plus 2i. It could be -3 minus 2i. It could be any combination of those. So it covers the integers and the imaginaries. So every polynomial function P of X can be factored into n linear factors, with n being greater than or equal. So our polynomial function can have a constant coefficient Now, what the fundamental theorem said is every polynomial function has to have at least one zero in the complex set. So no matter what the polynomial, even if the degree is 5, even if n equals 5, our polynomial could be n minus 1 to the 5th. So our 0 is at x equals 1, 5 times. So even though it's a degree 5 polynomial, even though it's a degree of 5, it still has to have at least one 0. Now, finding polynomials with given zeros. What does that mean? Finding a polynomial if I give you the zeros of 2 and -3. What is the function they came from? Remember, we have to work backwards. Let's just say it's a quadratic equation. We started off with this. The first thing we do is we factor it out. Then we set them equal to 0. Then we get our zeros. That's our traditional how we solve them. These are my zeros. Now we have to go from here back up there. We have to just reverse the process. So I start off with my zeros being x equals 2 and x equals -3. That's what I did with this first step here. Now I have to set them equal to 0. X minus 2 equals 0. X plus 3 equals 0. Well, those, if I multiply them together, they still equal 0. Now when I multiply them together, then I get my function. So that's what we have to do. We have to work backwards. Example 1. Find P of x of degree 3 having zeros, 1, 3i, and -3i. So to solve this one, we first have to set our zeros. First step, set x equals zeros, or set x equals to the zeros. So we have x equals 1, x equals 3i, and x equals -3i. Make them equal to 0. So x minus 1 equals 0. X minus 3i equals 0. X plus 3i equals 0. Then we have to multiply them together. And multiply. So we'll start for these two first. So we have x times x is x squared, positive 3ix minus 3ix minus 9i squared. We have x squared. The middle terms cancel. This I squared changes the sign in front of there. So we have x squared plus 9. And multiply them together. So x times x squared is x cubed. X times positive 9 is positive 9x minus x squared minus 9. So we have x cubed minus x squared plus 9x minus 9. That's my polynomial. Does it satisfy the conditions set forth in the original equation? I need a polynomial of degree 3 with these zeros. Well, it's going to be a degree 3 because we have 3 zeros. And sure enough, the degree is 3. Example 2. Find the polynomial of degree 5 with -1 as a 0 of multiplicity 3, 4 as a 0 of multiplicity 1, and 0 as a 0 of multiplicity 1. So we know the degree has to be 5. So look what we have. We're given that -1 is a 0 of multiplicity 3. The next one, 4 is a 0 of multiplicity 1. And 0 is a multiplicity, is a 0 of multiplicity 1. If we add the multiplicities, we get 5, which is our degree. So that checks. So where do we go from here? Next step would be what? Make them equal 0, yeah. So we have -1 equals x. That becomes x plus 1 equals 0. We have 4 equals x, so it's x minus 4 equals 0. And then we have 0 equals x, so x equals 0. So the product of all these zeros has to equal 0. But remember, it said that the -1 had a multiplicity of 3, 1, and 1. Multiplicity is the exponent. Because the sum of all your exponents has to equal 5, which it does. So we have to do this multiplication. So we do these two first, these two, then we put these together, and then multiply by x. We have x squared plus 1x plus 1x plus 1. That's this one. And this next one is going to be x squared minus 4x plus 1x minus 4. That's that. Combine like terms. Now we gotta multiply these two big ones together. X squared times x squared is x to the fourth minus 3x cubed minus 4x squared. That's it for the first one. Now the next one, we have 2x positive and positive times x squared. I could put that one under here, under the x cubed. I'm gonna line them up. Yeah, but line them up is much faster. And we have positive times negative is negative. X times x, so 2 times 3 is 6, x squared. Positive negative is negative. 2 times 4 is 8x. That's it for that one. And then 1. Positive times positive is positive, so we have x squared minus 3x minus 4. All of this equals 0. So negative 3 plus 2 is a negative 1 x cubed. Negative 4, negative 6 is negative 10. Plus 1 is negative 9x squared. Minus 11x minus 4. Then bring this x down here. And then lastly, distribute that x in there. So we have x to the fifth minus x to the fourth, 9x cubed minus 11x squared minus 4x equals our polynomial. If you want, yeah. It's about, yeah. I don't know what they're doing up there. All right, so that's how we do that. So we start with the answers, work our way back up to the question. But remember, the multiplicities are the exponents of those zeros. Oop, not fighting, I'm sorry. We're looking at zeros of polynomial functions with real coefficients. Real zeros of polynomial functions with real coefficients. We have to be very careful about here that whenever we have a complex or rational solution, whenever we have an x plus ai, we have to have a minus x minus ai. These are called conjugate pairs. Why is that important? Because whenever we multiply these together, what do we get? We get x times x is x squared, negative x ai, positive x ai, minus a squared I squared. Middle terms cancel. This I squared changes a sign in front of there, so it becomes a plus. So this gives us a real coefficient. X will be a number, and I square it, I add it to A, which is a number, and I square it. It gives me a solid. There's no imaginary numbers left in there. So whenever you have an answer that's imaginary, you have to have its conjugate pair with it. They always come in pairs. So, and also with, this is with the, also with radical coefficients. They must have their conjugate pair. In other words, if I had x plus square root of a, then I automatically have to have x minus the square root of a. This is what makes it conjugate. It's just a sign between their changes. Let's multiply these out together. Because remember, the section is with real coefficients. So if our answers are radicals, we have to know automatically it's conjugate. So x times x is x squared. So we have negative x radical a plus positive x radical a minus radical a is radical a squared. The middle terms cancel. Square root and the square cancel. So we have no more radicals. Follow that so far? All right, so let's look how this examples we'll use. Example 3. Suppose a polynomial function of degree 6 with rational coefficients has -2 plus 5i, -2i, and 1 minus radical 3 as 3 of its zeros. Find the other zeros. Remember, it's a polynomial of degree 6. So what does that tell us? If it's a degree 6, degree 6, we have 6 zeros. So we have -2 plus 5i, we have -2i, and we have 1 minus radical 3. That's 3 of them. So that's x equals this one, x equals that one, and x equals that one. So we need 3 more. What are those 3 going to be? -2 minus 5i, because we just change the sign between there. Change the sign in front of that, so it makes it positive 2i. And x equals 1 plus radical 3. Just change the sign between there. And those are our 6 polynomials, our 6 zeros. Pretty straightforward. Then comes the hard part. We have to multiply these, make them equal 0, then multiply together. And yeah, it'd get very big and ugly real quick. Example 4. Find a polynomial of lowest degree with rational coefficients negative radical 3 and 1 plus I as two of its zeros. Find the polynomial of lowest degree with rational coefficients negative 3 as two of its zeros. Because remember, so far, it gave you, what are these? Those are zeros. So automatically, there's a degree too. So we know that x is equal to radical 3 and x equals to 1 plus I. Okay, so what do we need? How many more do we need? Well, since this is a radical, it's negative, I need its conjugate. So I need to have that one. I need to have, this is a complex number, I need to have its conjugate. So my degree will be 4. These are the other two zeros that are missing. So let's find the polynomial. Because that's what it asks. It has said, find the polynomial of lowest degree. So we have each of these. We have x is x plus radical 3 equals 0. X minus 1 minus I equals 0. X minus radical 3 equals 0. And x minus 1 plus I equals 0. So our polynomial will be x plus radical 3, x minus radical 3, x minus 1 minus I, x minus 1 plus I. So multiply these two sets together. X times x is x squared. Negative x radical 3. Positive x radical 3. And then positive times negative is negative. Radical 3, radical 3, radical 3 squared. That's the first one. And then now the second one. X times x is x squared. Positive times negative is negative. X times 1 is x. Positive times positive is positive. X times I is xi. Negative 1 times x is negative x. Negative negative is a positive 1. Negative times positive is a negative I. Minus xi plus 1 plus I. So this is negative xi. This becomes negative is a positive I, negative I squared. middle terms cancel. We have x squared minus x squared and squared cancel, so we have 3. X squared. Combine like terms. Negative x is negative 2x. That gets rid of those two. Positive xi, negative xi, those cancel. Negative I, positive I, those cancel. This becomes a positive 1. 1 plus 1 is 2. And then we got to multiply these two together. So positive, x squared is x to the 4th. Positive, negative is a negative. X squared times 2x is 2x cubed. X squared, positive times positive is positive. 2 times x squared is 2x squared. Negative times positive, negative. It's under the x squares. Negative 3x squared. Negative times negative is a positive. 6x. Negative and positive and negative, 6. So our polynomial then becomes x to the 4th minus 2x cubed. 3 minus 2 is 1, so it's negative x squared plus 6x minus 6. And there's our answer. So far, so good? Okay, now things change. These are I gave you the answers and you find me the question. Okay, now we're gonna look at bigger ones. This is where it starts getting complex, lengthy, more so. Look at integer coefficients and the rational zero theorem. Rational zeros theorem. Rational zero theorem says this. You have a polynomial of degree n. Well, we set for this example, for these examples, we'll call the a sub n, the leading coefficient, we'll call that q. And we will call the last one p. Or the leading coefficient is a sub n, and the tailing coefficient is p. What we're going to look for here is this. The reason it's called a rational zero theorem, it says this. By taking p over q, The P over Q factors. We'll find sum of the zeros of our by sum, I mean the integer solutions. So we'll find some of the zeros, only the integer or rational ones, I should say. Because P over Q, they're both integers, or it becomes a rational expression. This method is very lengthy and it uses the synthetic division a lot. Here's example 5. A polynomial is made up of 3x to the 4th minus 11x cubed plus 10x minus 4. So this is our Q and this is our P. So first thing we do is take P over Q. So it's 4 over 3. It's not 4 over 3. It's not a fraction. It's the factors of 4 over 3. So what are the factors of 4? 1 times 4 and 2 times 2. What are the factors of 3? 1 and 3. But we don't know if they're positive or negative. So we're looking at the positive and negatives of each one of those. Now, what does this do? Because originally, if I just gave you this polynomial here and you started plugging numbers in there, how many x's can you choose from? Infinite many. If you remember, if you can pick, you can choose from infinite number of them, positive, negatives, even fractions. So what this method does, it now takes this polynomial, narrows down from infinity to these possibilities. Let's see what they look like. It could be positive or negative 1 over 1, positive negative 2 over 1, positive negative 4 over 1. Or it could be positive negative 1 over 3, positive negative 2 over 3, positive negative 4 over 3. So what we've done is we've gone from infinite many answers, possibilities, down to these 12. Because our nerves, what this says, our possible zeros are plus or negative 1, plus negative 2, plus negative 4, plus negative 1/3, plus negative 2/3, plus negative 4/3. We have those 12 numbers to try. All right, so let's start taking the first one. Let's try this one. So let's take positive 1 and put it in synthetic division of our polynomial. We have x to the 4th, x cubed, x squared, x, and a constant. So the coefficient of x to the 4th is 3, negative 11. There's no x squared, 10 x's, and negative 4. Bring down the first one. Now multiply. 1 times 3 is 3. And add straight down. Negative 11 plus 3 is negative 8. Then multiply again. 1 times negative 8 is negative 8. Add straight down. 0 plus negative 8 is negative 8. Multiply again. 1 times negative 8 is negative 8. Add straight down. So 10 minus 8 is 2. And 1 times 2 is 2. Minus 4 is negative 2. That's not a 0. So positive 1 is not a 0. Let's try negative 1. So we have 3, negative 11, 0, 10, and negative 4. Bring down the first term. We did go over synthetic division, didn't we?
Yes, sir.
Okay. So multiply. Negative 1 times 3 is negative 3. Plus negative 11 is negative 14. Negative 1 times negative 14 is positive 14. Plus 0 is positive 14. Negative 1 times 14 is negative 14. Negative 14 plus 10 is negative 4. Negative 1 times negative 4 is 4. Add those. We got a 0. So that tells us that x equals negative 1 is our first 0. Well, no. We know we have to have 4 answers. So we found one of them. We don't have to use this one anymore. Now we can use this one. We start from that one. Let's factor up, right? So we always start with, in case you have a multiplicity, start with this one again. Now we use these. We have 3, negative 14, 14, negative 4. Bring down the first one. Negative 1 times 3 is negative 3. Negative 14 plus negative 3 is negative 17. Negative 17 times negative 1 is 17. 31. That's going to get pretty big. So there's only one negative 1 as an answer. Okay, so we've tried 1 and negative 1. We're done with that one. Now we got to do 2 and negative 2, then 4 and negative 4, and keep on going till we find 3 more. So we tried 2. 3, negative 14, 14, negative 4. 2 times 3 is 6. 14 minus 6 is going to be 8. 2 times negative 8 is negative 16. Makes it negative 2. 2 times negative 2 is negative 4. And negative 8. Nope, that's not it. Let's try another one. Negative 2. 3, negative 14, 14, negative 4. Bring the first one down. Negative 6 makes it negative 20, makes it 40. And that's okay. But just keep on going. Let's see. Yeah, 2 and negative 2s are out. So then we try, what's the next number? 4. 3, negative 14, 14, negative 4. So it's 12, makes it negative 2, negative 8. 14 minus 8 is 6. 24 makes it a 20. So 4 doesn't work. We try negative 4. 3, negative 14, 14, negative 4. Negative 12. Oh, that's not going to work because it keeps on going bigger. So we see that negative 4 is not going to work because that's going to be a positive. So it'll be 118, and that's going to be negative. So that one's not going to work. So then we try 1/3. One third times 3 equals 1 equals negative 13. Negative 13 times 1/3 is negative 13 thirds, which means we have to convert that. This is 14 over 1, so it's multiplied by 3. 42 over 3. So 42 over 3 minus 13 over 3 is 29. And that's only to get bigger fractions. So that one's not going to work because when we multiply it, we'll get 29 over 6, and 6 times 4 is 24. It's not going to be so positive 1/3 is not going to work. Negative 1/3. Negative 1/3 times 3 is negative 1. Negative 14, negative 1, negative. Oh, looks promising. Because negative is a positive. 1/3 of 15 is 5. 14 plus 5 is 19. Nope, it's not gonna work because now we have a number that's not divisible by 3. Because we need to have a constant. So that one's not gonna work. Three, negative 14, 14, negative 4. Three. So 2/3 times 3 is 2. Those are 3's cancel. Negative 14 plus 2 is negative 12. The answer would be negative. 12 divided by 3 is 4. 4 times 2 is 8. 14 minus 8 is 6. Positive is going to be a positive. 6 divided by 3 is 2. 2 times 2 is 4. We got a 0. So here's our next answer. X equals 2/3. We have two of them now. We have x equals -1 and x equals 2/3.
No, we started now.
Now we don't have to use this, right? But here's the best thing about it. Once you get down to this level, which what kind of equation is this? Remember, this is the constant. This is a x part, and we have 3x squared. So now we have a quadratic equation. If we can't factor it, then we can use quadratic formula. But we know in this one, they're all divisible by 3. And this cannot go in a factor like this. So we got to use quadratic formula. So we have to take this equation and put it into that. A is 1, B is, let's see. Yeah, see, whatever you have, whatever your degree is, whatever it takes, once you get a quadratic equation, you're done with the long division, the synthetic division. You just do this now. So let's go ahead and find this equation. So we have, I should put it on the side. -b plus or minus b squared 4ac over 2a. A is 1, -4, and 2. Negative of a -4, -4 squared, two times 1. So 4 plus or minus 16 minus 8 over 2. 4 plus or minus 16 minus 8 is 8. Square root of 8 is the same thing as square root of 2 times 2 times 2. There's 2 of a kind, so it's 2 radical 2. 4 plus or minus 2 radical 2 over 2. On top, we can take out a 2. They both have a 2 in common. Those cancel. So x is equal to 2 plus or minus radical 2. So we have x equals -1, x equals 2/3, and x equals 2 plus or minus radical 2. Which then that makes our polynomial remember, each of these have to be, well, before we do that, each of these have to be set equal to 0. So we have x plus 1 is equal to 0. This one's a fraction, so we have to multiply by 3 first, and then subtract by 2. And we have 2 plus radical 2, and x equals 2 minus radical 2. radical 2. But we forgot one thing. We forgot the 3 in the front. Remember, back here, we factored out the 3. We took this one and solved it. We factored out the 3. I gotta put that 3 back in there. So there's our polynomial. All right, so let's look at the next example. Because then we can narrow it down even further. Example 6. We have f of x equals 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared minus 30x plus 15. Factor. Factor this equation out. Find me all the zeros and factor it. So what we have to do, remember, it's P over Q. Remember, this is P and this is Q. So we have 15 over 2. What are the factors of 15? 1, 3, 5, and 15. 15 and 1 is a factor as well. And of 2, it's 1 and 2. So our rational zeros are positive, negative 1 over 1, 3 over 1, 5 over 1. But we'll take each one of these separately. Then we have positive, negative 15 over 1. That's all of these on top of 1. Then we do the same thing with the 2. We have plus or minus 1 over 2, plus or minus 3 over 2, plus or minus 5 over 2, and plus or minus 15 over 2. 1. We have 1, 2, 3, 4 times 2 is 8. We have 16 things to try. So let's begin. The first one we try is 1, negative 1, positive 1. We have x to the 5th, x to the 4th, x cubed, x squared, x and a constant. So we have 2, negative 1, negative 4, 2. So 2 makes it 1. 1 times 1 is 1. 4, negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3 plus 2 is negative 1. 1 times negative 1 makes it negative 31. Negative 31 makes it negative 16. Nope. So are you okay with the synthetic division? But here's why. Because this is not going to work, that's not going to work, that's not going to work, that's not going to work. The first one that's going to work is that one. So you have to go through all, you'd have to go through all those. So let's look at this. We have 2, -1, -4, 2, -30, 15. So 1/2 times 2 is 1. 1 minus 1 is 0. 1/2 times 0 is 0. Minus 4 is -4. 1/2 times -4 is -2. Plus 2 is 0. 1/2 times 0 is 0. Minus 30. 1/2 of -30 is -15 and 0. So x is equal to 1/2. That's our first 0. We have 4 more to go. So looking at this now, here's the beauty of this one. That's our constant. This is x squared, x cubed. So we have 2x to the 4th minus 4x squared minus 30. Quadratic. So we can factor out a 2.
Is it possible to still do synthetic division even once you?
Get to this point? Yeah. You get the same values. It's just that once you get to something that's quadratic in form, it's much easier because you have to do it. You don't have to try each one of those anymore. And it'll save you a chance of making a mistake. Because with these, if you forget a sign or do something, a sign wrong, then it's going to ruin your day. So once you get to this point, pretty much use synthetic division. So we can factor out, we're looking for x squared. So it's x squared. Remember, you're always solving for the middle term. What times what is 15? When you subtract them, you get 2? Oh, yeah, we have opposite signs. And 3 and 5. The bigger sign has to be negative. So it's 5 and 3. So we have x squared plus 3 and x squared minus 5. Because we already know that 1/2 is one of our solutions. So x squared equals -3, x squared equals 5, square root both sides. X equals plus or minus radical -3. X equals plus or minus radical 5. Since that's a negative inside there, it's plus or minus I radical 3. So those are your 5 answers. Those are your 5 factors. We have x equals I radical 3, x equals negative I radical 3, x equals radical 5, x equals negative radical 5, and x equals 1/2. 1, 2, 3, 4, 5 answers. Set them equal to 0. And so 2x minus 1 equals 0. Remember, whenever your answer equals a fraction, whenever your x equals a over b, it will become bx minus a equals 0. Because you have to multiply the denominator and subtract the numerator. So that 1/2 will become 2x minus 1. Remember, we have that 2 we factored out. Is that 2? Yeah, right here. We factor out 2. We can't forget that 2. So our polynomial is going to be 2 times x minus I radical 3, x plus I radical 3, x minus radical 5, x plus radical 5, and 2x minus 1. That's our solution. Now there's a way we can go even further and reduce the number of possibilities that we have to try. Further reduce the number of attempts. We can use Descartes' rule of signs. Descartes' rule of don't worry about writing everything down because that's what I mean. Yeah, we're almost gonna be out of time, so I'm gonna keep on moving real quick. Example 7. Here's Descartes' rule of sign. Here's our polynomial. 2x to the 5th minus 3x squared plus x plus 4. Descartes' rule of sign says that we count the number of sign changes we have. That's going to tell us the number of positive solutions. Is this a sign change? Yes. This is positive to negative. That's a sign change. Negative to positive. That's a sign change. Positive, positive. No. So we have 2 sign changes. So we can have 2 or 0 positive solutions. The reason being because if you have conjugates have to come in pairs. So that's why you subtract whatever you get here, subtract by 2 until you can't go any further. So that's the number of positives. The number of negatives, we change the sign of x to negative. And the only thing, this negative, since that's an odd exponent, will go out in front. Since that's even, it'll cancel. This one becomes a negative. Now, for my number of negative solutions, how many sign changes? Is that a sign change? No. That one? No. So here we only have 1. So we're only going to have 1 negative and 2 or 0 positive solutions. Which tells us what? Well, we have to have 5. At most, this is 3. What happens to the last 2? They're going to be conjugate pairs. Right. So we could have 1 negative, 2 positives, and 2 conjugate pairs, or 1 negative, no positive, and 4 conjugate pairs. So that's the beauty, because now we just narrowed down the number of options that we have. So let's see here. Yeah, if you want, you can take pictures before we leave today. Example, because I know we're running out of time. I don't know where it went. 2x to the 5th minus 5x squared minus 3x plus 6. So how many positive solutions and how many negative solutions am I going to have? So positives. Is that a sign change? Yes, that's 1. Is that a sign change? Is that a sign change? So that's 2 or 0.
Positive also gonna have it or zero.
Well, all of them do. If this was a 2 or 3, then you subtract
This
2.
is one.
If it, yeah, other than 1, if if either of these have 2 or more, then you have to subtract 2. Because there could be conjugate pairs, like we just saw. So now we have to go to negative x. Shortcut is if it has an odd exponent, then just change the coefficient. That's even, leave it alone. That's odd, so I change that. So, nope, that's 1 sign change, so it's 1. It's the same thing. So we can have this. We're supposed to have the degree. We're supposed to have 5. We have positives, negatives, and conjugate pairs. So we can have 2 and 1. That means we have to have 2 of these. We have to have 1 negative, or we have 0 of those, so we have 4 of these. And that'll help us to see what we have to get to. It doesn't tell us what they are, it just tells us how many we have. 5x to the 4, 3x cubed, 7x squared, minus 12x plus 4. So how many positives and how many negatives? Yeah, so it's 4, or 2, or 0. Because it's 1, 2, 3, 4. Now, how about the negatives? Do we change that one? No, because it's even. We change that one. We don't change that one. We do change that one. So how many sign changes do we have here? Do we? They're all positive. So our possibilities, our degree, our n is 4. So positives, negatives, and conjugate pairs. So we have 4 or 0, 0. We have 2, 0, or 2. Or if it's 0, 0, then we'll have 4. Those are our possible outcomes. Make sense? I know I'm going pretty quick. I'm so sorry. If you want me to, I'll go over this next time. Example 10, P of x is equal to 6x to the 6 minus 2x to squared minus 5x. So how many positives, how many negatives? Yeah, 1 positive. How many negatives? The only one that changes is that one, because that's even, doesn't change, doesn't change. So how many sign changes? Or 0. We're supposed to have 6. So we have, this one has to stay 1. This one's 2. We can't do it because this one has to be even. So this can't be true. So we have 1, 0, and 5. That can't be true. So that means all of them are going to be. No, this will be 1. This has to be 4. No, can't be. Ah, that's why. Because notice they're all x's. So a 0 could be 0. 0 is one of ours. So we only have 5 left. So that's 1. This could be negative, had to be 2, so it's 2, so that could be 2. This could be 1, that could be 1. That could be 0, so that has to be 4. That could be, that has to be 1. This has to be 1. And so this one has to be, no, there's only 2 possibilities here. We either have 1, 2 conjugates and 1 0, or 1, 4 conjugates and 1 0. That's that. Okay, you want to take pictures of these last few pages? I don't know where I derailed you.
It was just a, but
I'm good today. It just, I looked up, and that's horrible. Thank you very, very much. Yeah, and if it doesn't make sense, we can always go over it again whenever you get ready to do the homework assignments on them.
okay. Because actually, look, when we got to, it's just, it's like wrong having to repeat.
That synthetic division.
Until you do a quadratic.
I know, as I said, that's the worst part about this section is it's very drawn out. Imagine doing that one over and over till we get to 1/2.
Imagine you going and then messing up.
Messing,
And you mess up everything after that.
it's happened before. I had students in the long ones, they wrote the question down wrong, so when they put the synthetic division, they put the wrong numbers there all over. And oh man, talk about yelling expletive.
All right, yeah, but.
You too, thank you.